Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question number 24 of 2014 JEE Advanced Physics Paper 2. So let us start with question number 24. Hello students, let us start with question number 24. So far we have solved 23 questions. That means this is the fourth question of paper 2. We have numbered them as 20, 21, 23 and 24 like that. So in this question it says that charges Q, 2Q, 4Q are uniformly distributed. So you can see that the charges Q here, 2Q here and 4Q are uniformly distributed in three dielectric solid spheres. Dielectric solid spheres means non-conducting sphere. So that means charges will be present inside and on the surface as well. Spheres are 1, 2, 3 as given, sphere 1, sphere 2, sphere 3 of radii r by 2, its radius is r by 2, its radius is r, and the third one is having radius 2r. Now if magnitudes of the electric fields at P is the point, at the point P at a distance r from the centers of spheres. So we will consider a point P which is at a distance of r from the center of each sphere. So for the initial sphere, which is a smaller sphere having radius r by 2, this point will be the outside point. For the second sphere it is the point on the surface, and for the third sphere whose radius is 2r, this point P lies inside the sphere because that distance is r. So here you can see it is the inside point, here is the point is on the surface, this point is outside. Now what you have to find? These electric fields are E1, E2 and E3 respectively. Then you have to find which of the relation is correct. Now because this is a solid non-conducting like dielectric spheres, so for the first one, so the first sphere 1, it has radius r by 2. This radius is r divided by 2. The point is lying outside because this is the center and this distance is r from here to this point, and this is given a charge q. This is given a charge q, and this point is a point which is lying outside the sphere. So for an outside point, the distribution this will behave like a point charge. This will behave like a point charge. So as if the whole charge q is concentrated at the center. Why it is so? Because if I take a Gaussian surface including this point, I take a Gaussian sphere, this is a Gaussian sphere, then I will consider a small element over here of area ds. Then the ds vector and E vector will be in the same direction, and Gauss theorem says that E dot ds, so in this case it is E1 because electric field is given as E1, so it is E1 ds. Integration over the closed surface, this surface is Q enclosed divided by epsilon naught. If I use this and proceed further, the integration of epsilon naught E1 ds is E1 ds cos of 0, and this is Q enclosed. The total charge enclosed within the solid sphere of smaller radius r by 2 is q, because we have given charge q and that is enclosed within that Gaussian surface. So therefore this is the charge q, this is the total charge that is given to the sphere divided by the epsilon naught. This is the closed surface and this is a sphere. So and this is the closed surface of the Gaussian surface, and Gaussian surface is a sphere of radius capital R. So therefore this E1 being constant in magnitude, because we have considered dot product, it is the magnitude. The magnitude is same because that center point will be equidistant from the sphere. So therefore I will write this one as E1, and cos 0 is 1, ds is 4 pi r square. This is r square. So therefore this is equal to q upon epsilon naught, and from here E1 comes out to be q upon 4 pi epsilon naught r square, which is kq upon r square. This is equation number 1. Okay, so first we got the E1 value for the first sphere, then we'll move to the second sphere and see what is we're getting for this sphere, what is E2 over at this point. That E2 will find out here. This is the E1 we got here, and similarly for this point we will get E3. So let us find for the second sphere. Sphere 2, it is a sphere of radius, radius is given r, and the charge that is given to this sphere is 2q. It is given in the question, is 2q charge is given, and it is uniformly distributed throughout the volume of this also, because it is dielectric solid, so charges is present outside the sphere and inside the sphere, on the surface and inside. Now if I consider a point which is at the distance r, so obviously this point will be on the surface. So this is the point, and if I consider a Gaussian surface enclosing that point, it is that Gaussian sphere. That Gaussian sphere encloses the whole of the charge q. Okay, whole of this charge which is dq. So for this point, if I apply the Gauss theorem, again I will have, because the direction of E and ds for smaller element will be same, and at each point it is same, so I have to integrate it. E2 ds, ds integration of the closed interval, integration of closed interval ds. Which surface? This is the Gaussian surface, the dotted one, and the surface itself is the same, and this is the total charge that is given is 2q is enclosed here, so it is 2q divided by epsilon naught. This is Gauss theorem. Now this ds closed interval, ds integration closed interval will be the area of this Gaussian sphere, which is 4 pi r square. So from here I will get E2 equals to 4 pi epsilon to come down, 2 kq upon r square, 2 kq upon r square. This is equation number 2. So we have got two equations, so one is here and another is here. You can see here E1 is kq by r square and E2 is 2 kq by r square, so E2 is obviously greater than E1, that we have got it. So from these two equations 1 and 2, we have seen that E2 is greater than E1. Then also you have to find the electric field that is due to the third sphere. What is that third sphere? The third sphere, we'll see for the sphere number 3. This is third sphere, and The charge that is given is 4q. 4q is the charge given, and its radius is 2r, and we are considering a point at a distance r. So this point P lies within the sphere. Within the sphere. Now, for within a sphere, this is the Gaussian surface that is we have considered. This is the Gaussian surface. So, as usual, we'll consider one element over here, and because of that element of area, say ds, the ds vector will be outward, and the electric field will be also pointing in the same direction. The electric field also will be pointing in the same direction because it is a symmetrical arrangement of the charges. When the charges are symmetrically arranged, if you consider a small area over here, then the electric field will be normal, radially outward. We know that electric field will be radially outward from a charge cylinder or charge sphere. So it is radially outward, and the normal to this surface is the area vector. So both are in the same direction. So this direction is also the direction of electric field vector, that is E3. Because both are in the same direction, again by applying Gauss theorem, we have E3 dot ds, this vector, integration over the closed surface, which is this surface, this Gaussian surface, whose radius is r. This equals to q enclosed divided by epsilon naught. Q enclosed, that is what you have to find, because when I have given 4q charge, the 4q charge is distributed uniformly over the volume of the sphere. Okay, this means what? This means that the 4q charge is present here. So in this Gaussian surface that I have given in dotted form, this one, I will make a red one to see it visible. So our Gaussian surface is this one. This is our Gaussian surface, and this surface does not enclose the whole of the charge 4q, because some charge is present within the surface and some charges are present outside. So we have to find how much charge this Gaussian surface encloses. That value we have to put it here. So to find how much charge, this is uniformly distributed. So per unit volume, the charge we have to find, this is uniform. So you think of this rho stands for volume charge density, that is the charge per unit volume. The total charge is given 4q, that is distributed over the volume 4 by 3 pi of this distance is 2r, so 2r whole cube. This is the volume charge density. If I want to find the charge enclosed here, that implies enclosed charge equals to this volume charge density multiplied by the volume of this Gaussian surface, volume of Gaussian sphere, which is this multiplied by 4 by 3 pi of this RQ, because R is the radius of the Gaussian sphere under consideration. So multiplying these two, we'll just simplify and see how much Q enclosed we are getting. The enclosed charge Q equals to, that we have already got, this is 4Q divided by 4 upon 3 pi 2RQ multiplied by the volume of the Gaussian sphere, that is 4 upon 3 pi small r q. If you solve this, then 4 by 3 pi will cancel out. This is 4Q. Here it is RQ divided by 8RQ. So from this RQ also will cancel out, and here it is 2. So it is Q by 2. So the charge which is enclosed within the Gaussian surface is Q by 2. If charge enclosed is Q by 2, then our equation here will be what? This will be Q divided by 2 epsilon naught. Now this part I have to solve and proceed. Now let us solve that part also. That says that because electric field is same in magnitude, because that point is whatever is the charge present, for that charge enclosed, that is radially outward for all the small elements elementary area we consider. So therefore E3 comes out ds integration cos of s, this is equal to Q upon 2 epsilon naught. I am writing this from here. Q upon 2 epsilon already you have got. This one E3 comes out, ds integration you have to take, because the angle between E3 vector and ds vector is 0. This is a sphere and whose surface area is 4 pi r square. This is Q upon 2 epsilon naught. So from here I will write E3 as Q upon 2 4 pi epsilon naught and r square. So 1 upon 4 pi epsilon naught is k. So this is k q upon 2r square. This is equation number 3. So kq upon 2r square. Now we'll write all those 3 equations that we have got so far. The equations are, I'll write one by one here. The equation number 1 was kq divided by r square. Equation number 2 was 2kq by r square. 2kq upon r square. This is equation number 2. You can see here that kq by r square is here, kq by r square is here also, kq by r square is here also. If I neglect kq by r square because it is same for all, here it is half 1 by 2, here is 1 is 2. So here it is 1, here is 1 by 2. If I neglect this value, or I can make it 1, then this value is 1 and this value is 2. So obviously we know that 2 is greater than 1 and greater than half. So E2 is greater than E1 is greater than E3. E2 is greater than E1 is greater than E3. This would be the answer to this question. And if I see that E2 is greater than E1 is greater than E3, so therefore the option number 3 is correct. Okay, thank you.